welcome to the budgeting revision session for December 2020. And today we're going to do learning curve. Actually, it's a very important area, not just assessed in budgeting, but actually it's a phenomena. It's a human phenomena just to calculate your labor cost. Okay, as we, for example, if a process is complex, okay, if it's repetitive, again, if we are doing it for the first time and there's a scope of learning in it, then there's this phenomena known as learning curve effect, which says as we get familiar with a new product, it's a human phenomenon, we just get faster and faster. Let's say you're producing a desk, or even, for example, if you're making a new dish you haven't tried before, like you're making pizza for the first time, which is itself a complex thing. Like you're baking for the first time, you have to be really good with ingredients and all that. And as you continue to produce those things, continue to make those things, you'll ultimately get faster and faster. You'll get to know the technique, okay? Or to any complex, you're doing any design project for the first time, you're a craftsman making a boat or an airplane. Definitely there's a learning curve effect, which says that as the cumulative output doubles, okay, there's a doubling rule that needs to be applied, okay? And it was for the first time, there was a plane engineer, right, who actually discovered this phenomena for the first time, that as he continued producing the plane, he actually felt that the learning curve effect, or the learning rate, was actually constant. It wasn't varying, but it was constant as the cumulative output doubles. For example, from 1 plane to 2, from 2 plus 2, 4, from 4 plus 4, 8, from 8 plus 8 to 16, 16 plus 16, 32. Only when the output doubles, he felt that the cumulative average time per unit, the average time per unit falls by a fixed percentage until a time comes, obviously, when it's a human phenomenon, and at times come when learning actually stops, okay? And the per unit time actually stops and it remains constant. And for example, after making 100 desks, okay, the time taken per desk is only 5 hours. So for all the desks after 1,000, it will only take 5 hours per unit, and it's not going to take, it won't come down to 0. So a steady rate is reached, okay? If you're going to draw a graph of cumulative production and cumulative average time per unit, okay, it just decreases, but it didn't just get flat after that. Because even if you want to drink water, you need time for that. It's not that the time is gonna get to 0, okay? So it's not gonna come down to this, it will just ultimately. So after 50th, for example, unit, the time, actually the learning rate, that steady rate was reached and the learning actually stopped. Okay, a little theoretical concept about that is, and this learning curve is really important whenever you are calculating, for example, the labor cost, whether it's budgeting, whether in any of the advanced costing techniques like target costing, like life cycle costing, whenever there is labor cost that needs to be calculated, or labor hour working, that will imply this learning curve effect. And there are two formulas to calculate that cumulative, two methods, I would say, that is used to calculate that cumulative average time per unit, okay? One which says that as the output doubles, which is known as the double approach, okay? And the other one is incremental unit method, or the formula approach. And cumulative average time per unit there is calculated by a formula, y equals a x b, where a is the time taken for the first unit, y, you get to calculate your cumulative average time per unit. It could be batch, could be anything, okay? So time taken for the first unit or time taken for the first batch. And x is basically the number of batches or number of units, okay, for which you want to calculate the average cost per unit. And b is basically known as the learning index. And how you get to calculate that? log of, you need to know the learning rate. Okay, for example, the learning rate is 80%. A is the time taken for the first unit, and it takes 12 hours to produce the first unit, right? And how you calculate B here, which is the learning index. So log of learning rate in decimal, right? So it's going to be log of 0.8 divided by log of 2. You need to put these brackets before you're applying the formula, okay? And you should learn how to perform this in Excel, and also how to perform all the calculations on the calculator. Why? In Excel, because it can be assessed in section C, and for calculator reasons, it can be assessed in section A and section B as well. Okay, so whether any question on budgeting, labor hour working, labor cost working, or from advanced costing technique like target costing, like ABC costing, it could be assessed anywhere. Even in variances, it could be assessed. Could be assessed anywhere. Okay, so the two approaches, double approach and the incremental unit method. So why the two methods are different, and what are the conditions that needs to be there in order to apply this phenomena? Product should be new, should be repetitive, it should be a human intensive work, not machine based. Then only since it's a human phenomena, then only there'll be scope of learning. Okay, a product or service needs to be complex, because for a simple product you could finish it in a few seconds, few minutes. It won't be very complex. And there shouldn't be any breaks in production. Even if I'm making pizza, and if I make it for the first time, and the next pizza I make it after 3 months, definitely I would be starting all over again. I made one desk now, and the next I'm making after 5 months, definitely I would forget. They won't be. So there shouldn't be any the process should be continuous. There shouldn't be any breaks in the production. I have a question here. I haven't started any calculation yet. Where is 2? 12. Let's suppose the time taken for the first unit is 12. Okay, I'll come back to it. Next is labor needs to be motivated. Okay, if I'm not motivated, I am not motivated to work, definitely I won't perform well. So maybe if I'm not motivated to work, the learning curve effect won't show. And the labor turnover should be low. First your team of 10, and then 5 leave you, and then you hire 5 back, and then the learning starts all over again. So it discouraged labor turnover should be low. Okay, and the two methods, double rule, okay, and formula approach. Why they're different, now I'm going to tell you. Okay, formula approach you calculate by this method. I already told you this is cumulative average time per unit, time taken for the first unit batch, cumulative production at batches, learning index, how you calculated, learning rate in decimal divided by log of 2. Next is double rule, cumulative average time per unit is calculated, a learning rate into previous average. Okay, for example, you need to remember the format. Okay, here I'm taking the cumulative units. Okay, and then here in the second column I'm going to calculate my cumulative average time per unit, and then in the third I'm going to calculate my total time, and then I'm going to calculate my incremental time. Okay, so this will be the total time for all the units, and this will be the average time. How is average time calculated? Basically, total time, right, for all the units divided by total number of units. That's how you calculate the average time per unit. Okay. So I told you, from if you're making the first unit for the first time, what is cumulative average time per unit? Time taken per unit is basically 12. Okay, and total time for one unit is 12 into 1. It's going to be 12, and the incremental time for first unit, I've just made the first unit, it's basically 12. Now the doubling rule applies. If I produce one more batch or one more units, now the cumulative collectively Okay, altogether, cumulative units are now 2. And altogether, what would be my cumulative average time per unit? So it's going to be, how I'm going to apply that, just apply the learning rate to this previous average. This is the previous average, right? Just apply the learning rate, okay, in decimal to the previous average. And that is 0.8, okay? So what would be the time taken, cumulative average time per unit for the second unit? So it's for the second cumulative unit. So it's going to be 12 into 0.8 and it is 9.6. Okay, that's the average time. Okay, when you produce two units together, right? And what would be the total time for 2 units? 9.6 is time per unit into 2. I would get the total time, which is 19.2. Okay. So this is the time taken for 2 units. This is time taken for the first unit. And now from here, if I want to calculate the time taken for the second unit, can I do that? So this is the time taken for the first unit, right? And here I want to calculate the incremental time for the second unit. How I'm going to do that? I'm going to do that. From the two cumulative time for 2 units, you can deduct the time taken for the first unit. That's how you're going to get the time taken for the second unit. Got it? 19.2 minus 12. Okay. Time taken for the second unit was 7.2. Okay. Here I move on again. And now output doubles again. 2 plus 2. Now the cumulative production is 4, right? Okay. Now, actually what's happening to this average, the previous average was 9.6. To this average, again apply the rate as per the double approach, which is basically 0.8. You're going to get the time taken for the cumulative time taken for the fourth batch, or for the fourth unit, which is going to be 7.68, right? So actually, it's like here time taken for the first time was 12 into R. Okay, if for the first batch, and then if I'm going to calculate here, it's going, for this, it's going to be 12 into R means 12 R square, right? 12 R square. I could calculate the same thing by using 12 as well. 12 into 0.8 into 0.8. See, you're going to get this figure. So this is cumulative time for 4 units, right? Okay, but again, it's average time per unit when 4 units are together made. This is cumulative average time for the 4 units, but it's per unit. Remember, always remember that. So now if I want to calculate the total time, what I need to do is I need to multiply it with 4, right? So the total time is 30.72. I hope you guys are, helping with the calculations. That's great. 30.72 it is, right? 30.72. Okay, from here if I want to, this is the total time for 4 units, right? And this is the total time for the 2 units. Okay, if I deduct from the total time of 4 units, I deduct the time for total 2 units, what I am actually going to get is going to get the time for the next 2 units, which is going to be 3 and 4. So here I get, if I deduct here 30.72 minus 19.2, I'm actually getting 11.52. What do you think it is? Actually, it's not time taken for the third unit. It's not time taken for the fourth unit. It's actually the time taken for third and fourth unit together. So I'm actually calculating right now cumulative average time per unit using the double approach. And why double approach is different? Double approach or Wright's model, it actually doesn't give you time for each unit. It only gives you time when the output is doubling and time in between, okay, as the units are doubled. It could be 4, could be telling a time for 8 units, but no, it doesn't really tell you the time taken for the third unit or the time taken for the fourth unit. It's not going to tell you that. And for that, if in a question, I'm asked to calculate the time taken for a particular unit, for one specific unit, I cannot apply the double approach. Double approach, I only get time taken for the first and second unit. And the next, I'm not going to get the individual time or the specific time for a particular unit or for any specific unit. In order to calculate the time taken for a specific unit, I need to apply this formula approach. Y equals AX B. Okay? And same, how you're going to get the, how are you going to apply the formula? Same, you need to calculate the cumulative average time per unit, but that's going to be a per unit time again. Okay, that's going to be a per unit time again, but again, using the formula. So here, if I proceed, if I make 4 more units and the unit would become 8, right? Cumulative units would become 8. And again, what's happening here? Okay, for the third time, it's doubling. For the second time, it was 12 into R, right? For the second time it doubled, it was 12R squared. And for the third time, it's going to be 12R cubed. 12 into R into R into R. Yeah? Or to the previous average, simply, the previous average was 7.68. Just apply 0.8 and you're going to get the cumulative average times for first 8 units, which is going to be 6.144. Okay? Or I could have done it like this as well. 12 into 0.8 into 0.8 into, yeah, you got it, into 0.8. See that. So this is the cumulative average time for 8 per unit for 8, and into 8, I'm going to get the total time for cumulative 8 units, right? And which is 49.152. 49.152. Again, this is the time for first 8 units, right? And if I deduct the time from first 8 units, deduct the time for first 4 units, what I'm actually going to get the time for additional 4 units, which is going to be after 4, which is basically 5, 6, 7, and 8. Okay, so now just deduct 49.152 with 30.72, 30.72. You're actually going to get 18 point. This is the time 4432. This is the time taken for 5th, 6th, 7th, and 8th units. So again, you're not getting time for any specific unit, for any particular unit by using double approach. For example, if a question was there, it asked you time taken for the 8th unit, for 6th unit, for 5th unit, for 3rd unit, for 4th unit. You cannot really calculate with the help of double approach. You need to calculate with the help of the formula approach in that case. Okay, so now I am going to importance of learning curve. Whenever labor cost, it affects the labor cost working, it affects the cost of the product. It can have an impact on the price of the product since labor cost is changing. It will have an impact on the budgeted cost, okay, labor cost. Even, for example, initially you thought that it takes 12 hours, but after making 50 units, you actually know that the time taken per unit is only 5 hours, okay? And this is the time on which you should be setting your budgeted cost. For example, I set it on the basis of this, my cost would be wrong. And then if you want to calculate the labor efficiency variance, that would be meaningful. That would be meaningless. Okay, so all variances, if all budgets are going to get affected, you also, with the help of that, you won't be able to calculate the right variance since the budgeted cost would be wrong. So when you're going to calculate the labor efficiency variance, you measure the standard hours and with the actual hours worked. Okay, if the standard would be wrong, labor efficiency into standard rate per hour. So in that case, labor efficiency variance would be a lot adverse. Okay, for example, if it was 12 and now standard time should have been 5, okay, and now the actual, for example, actual time was 4. So here it was adverse. For example, if standard rate was 2, here it was a lot adverse. But actually, when we saw the standard time was 5, not 12, because we didn't incorporate the learning impact here. So definitely this would become favorable. So this would have an impact on budget, price, cost. This would have an impact. We could inaccurately, that could result in inaccurate resource allocation. For example, the hours available are basically hour taken per unit is not 12, it's actually 5. Okay, but if I calculate my budget, that how many units I could produce, okay, how many units I could produce, and I'm just taking that time taken per unit is 12, I may be able to produce less, right? But after incorporating the actual learning rate and all that, the time taken per unit was only 5. So I could produce more units. So that's inaccurate resource allocation, inaccurate production budget, okay? I'll be needing more labor hours, okay, on the basis of this, which would be wrong. But when you're calculating the budgeted labor cost on the basis of the actual hours after the learning was stopped, that should be your standard, okay? I could do the resource allocation correctly. I could, because of not incorporating the learning impact, I could take inaccurate decisions. Yeah, I may be thinking that I'm not able to achieve my sales demand because I'm setting everything on that. And I thought I'll be able to produce, I won't be able to achieve my production capacity, my sales demand, because I'm not able to produce more. I have maybe, I have limited, I'm thinking that I have limited labor hours, but actually it's not the case, right? So this has implication everywhere. Okay, now 3 ways learning curve objective test questions could be examined. Now you're going to solve this question, okay? The first question I'm talking about. And now tell me which method you're going to use here. What will be the expected labor cost of the 5th unit? Now tell me, can you calculate with the help of double rule, double approach, or you will have to use the formula method in order to calculate the time taken for the 5th unit?
Formula method.
Yeah. Now just go ahead. How are you going to do that? I just told you, okay, how to calculate the incremental time, right? And here, I just want to calculate the incremental time of the 5th unit, right? 5th unit. So the format is going to be the same. Here, you're going to take the cumulative units, okay? Here would be the cumulative average time per unit, okay? Here would be the total time, okay? And here, uh, for 5 batches first, okay, I'm going to calculate the total time for 5 units, right, first. But for that, I need to calculate cumulative average time for 5 batches first. Then I would be able to calculate the total time for 5 units, right? And then also I calculate the cumulative average time for 4 units, okay? And then I calculate the total time for the 4 units. Then the total time for the 4 units. And now if I deduct, whatever the figures I get here, if I'm going to deduct from total time of 5 units, I'm going to deduct the time for taken to produce first 4 units. What I'm going to get, I'm actually going to get, with the help of the formula approach, the time taken for the 5th unit. Time taken for the 5th unit. Okay, by deducting this with this, I'm actually going to get the time taken for the 5th unit. Okay, so the first unit of an entirely new product took 160 labor hours to make. Okay, 160 is the cumulative average time. The time is the time taken for the first unit. Okay, okay. Then I'm going to calculate the learning curve. Here is 75%. Now I'm going to calculate this B, which is the learning index, right? And how I'm going to do that? Log of learning rate, which is 0.75 here. Okay, learning rate here is 75%. Log of learning rate divided by log of 2. Okay, I'm going to get my learning index. See how I'm going to do that in the calculator for you here. So first, 0.75 log of 0.75 divided by 2 log of 2. See, log of 0.75 divided by log of 2. I got my learning rate here, which is minus 0.415 5037 499. Okay, now I need to, with the help of the formula approach, I need to calculate the cumulative average time per unit first for 5 units. Okay, by using this. So how I'm going to do that? A is the time taken for the first unit, 160 into x. Here I'm going to do into 5 raised to the power this learning index minus 0.415037499. Okay, and see how I'm going to do that in the calculator now. 160 into 5, this I'm going to do that, raised to the power minus 0.415037499. Okay, is this? What's that, Mohammed? So it is 82.0916, I guess. Okay. And now I just multiplied it with 5, time taken for the 5 units. That is 410.19581. 410. Don't round it off. Okay. Just take at least 4 up to 4 decimal place. Always the answer. Otherwise, your learning effect is not, it would be vanished. Okay. So 410 into 195,814. Okay, that's the time taken for the first total time for first 5 units. Okay, now I'm going to repeat the same process with by using the same formula, time take 1, but for 4 batches now. Okay, now I'm going to calculate the cumulative average time per unit for 4 batches, and by using the learning 0.415. Okay, so it's going to be 160 into 4 raised to the power minus raised to the power minus 0.415037499, and this is basically 90. Okay, 90 point, okay, 90.000. Whatever is there in the calculator, just multiply it with 4 into 4. You're actually getting the time taken for the first 4 unit, which is 360. So this was 410 and this is 360. If I deduct from total 4 unit time for cumulative 5 units, I'm actually going to get the time taken for the 5th unit. Minus 410. Okay, 50.19581. That's the time taken for the 5th unit. Now we need to calculate the labor cost, not the time for the 5th unit, actually the labor cost. Okay, and what is the labor rate per hour? You have actually the cost for 160. Okay, 160 labor hours. You actually have the cost for 160 labor hours. From here you can actually get the rate for per hour rate, right? 3200 divided by 160, the per hour rate was 20. Okay, so now just multiply it with 20. Okay, so okay, so the answer is 1003.92. Actually, this is the rounding digit. Okay, if the number after the rounding number, if it is either equal to 5 or greater than 5, you actually increase the previous number by 1. So I'm actually going to write it 1003.92. That's my answer. 1003.92 is my answer. Okay. Next. Are you guys with me?
Yeah, ma'am.
Okay. You all got the answer right?
Yes.
Okay, very good. Yeah, 1003.92, that's the right answer. Okay. Now, the time for another way that learning curve objective test questions could be examined in your section A and section B, which is you can be asked to calculate the learning rate, okay? And you're going to use a double approach for that. See how I'm going to do this question. So here I am given the time for the first batch of 50 units is actually, I am given the time for the first batch, which is 500 units. And then I'm given the total time for the first 16 batches, okay? And the total time is 5731. I'm not given anything else. And I need to calculate the learning rates here. I told you the format is same, cumulative units, okay? And then cumulative average time per unit. I sent you a YouTube tutorial, how to take fourth root, fifth root, sixth root. Okay, I hope you guys have gone through that. So we will be using that as well here. So here what I'm given, actually, the time taken for the first batch, right? And which was the cumulative average time was 500, right? I am given this thing here. And then I know nothing, but I know one thing, that the output would be doubling again, okay, from 2 to 4 and then to 8, okay, and then plus 8 to 16. And then I'm given the total time for 16 batches, total time here, and which is 5731. I'm given the total time here, okay. So for 16 units, okay, how to calculate the cumulative average time per unit? How to calculate for 16 units, how to calculate the cumulative average time per unit? Using double approach, okay, from previous average, you always apply the learning rate. If it is happening for the first time, it's going to be 500 R, okay, for this, and for it's going to be 500 R square. For this, it's going to be 500 R cube third time, and then for the fourth time, here it's going to be 500 R 4. Okay, and how you get the total time? What you do? Number of units into time per unit. That's how you get the total time. So consider this is time per unit and this is total number of units. You multiply this and you're gonna get, this will be equal to your total time, this answer. So I can write it like this, 16 into 500 R4 is equal to 5731. Yeah. And now this R will, if you're going to solve this R, you're going to get your learning rate. What actually was your learning rate? So you could, at times the learning rate and everything is given and you actually calculate it, when sometimes it's not given and you have to calculate the learning rate. So in the double rule, just remember, okay, what is going to be the par for R, and you can actually calculate your learning rate from that, which is going to be in percentages, right? So how I'm going to solve this kind of a thing, you just get rid of the 16 here, divide both sides by 16 first, okay? 16, 16. This will be cancelled here and this would be 5731 divided by 16. This would be 358.1875. And this will be 500 R4, okay? And now you need to get rid of 500. So divide both sides by 500 this time. divided by 500. So this will be R4 now, and this would be divided by 500 to get 0.716375. 0.716375. And now just take a fourth root on both sides. This is gonna be R here, and here you'll be taking the fourth root. Okay, and I sent you the two type of calculators. I don't know which kind of calculators you're using. At times there is this square which is used to calculate this power. In some calculators it's like this, okay, but in some other sorts of Casio calculators, you first have to input the number, and in order to activate this you always need to press the shift and this button, right, in order to get it activated, and then give the number, and then you're going to be able to solve the power. And for the other kind of Casio calculator, you first need to input the number and then shift that, and then you would be able to calculate the rate. So what is the answer? If I solve this, the answer is 92%. Okay. Are you going to help me to do that
Yeah,
on
ma'am.
calculator? What's the answer?
92%.
Yeah, and then you multiply it with 100 as well, since it's in the percentages. So that's 92%. Okay. Now the last one here, what is actually the